Okay, so this is what we're going to find. We are going to find h of 2. So the first thing I want you to write down is h of 2. It needs to be in this form. And so some people had the right output, but they didn't have it in the right form in order to get the points. Also, although this is equivalent to this form, I really prefer this form better. This means, either one of these forms means take the value that we're going to input, first plug it into F and then into G. So I like this form better. So plug this into F, and then after I plug it into F, I'm going to plug it into G. So what value am I plugging in? 2. Let's put 2 into function F. Here's function F. The input is 2 and the output is 1. Now I did that for F. My output is 1. Now I'm going to take that output of 1 and I'm going to plug it into G. You absolutely can use a calculator. So here I have 1 squared. 8 times 1 is 8 plus 12. All over 1 squared is 1. 1 minus 4. So 1 plus 8 is 9. 9 plus 12 is 21. 21 over negative 3 is negative 7. This is the correct form for A. This next part asks us to evaluate the inverse of the function. So what I'm going to do really quick is I'm going to draw this. And 1, 2, 3, there we go. So I'm going to put my inputs, and then here is the outputs for the inverse. Now what I remember is that when we find the inverse of a function, we're just going to switch the inputs and the outputs. So these were the inputs, but now they become the outputs. These were the outputs, and it now becomes the inputs of the inverse of that function. So here's how I have to write this. I want to know the inverse of an input of 4. So the inverse function with the inverse with an input of 4. So I go to the inverse function, I input 4, the output is 16, and it has to be written in that form. So for part B, we're asked to identify all the horizontal asymptotes or state if nothing exists for horizontal asymptote. Hey, would you get the door for me? Hey, would you get the door for me? Would you get the door for me? Thanks.
Marvin?
The door. Can you get the door? So in this function, when the degree on top is the same as the degree on the bottom, can you please circle those? When the degree on top is the same as the degree on the bottom, we're going to look at the leading coefficient of the numerator and the leading coefficient of the denominator, and we're simply going to divide them. 1 divided by 1 is 1, but you can't just leave it as 1 because a horizontal asymptote is actually going to be an equation. It is y equals 1. Horizontal asymptotes will always be y equals, just like vertical asymptotes will always be x equals. I feel confident that kids understand this, but the way it was worded in the second part of B is confusing. So in this part B, it says go to function G and tell us if there's going to be any holes. And if there is a hole, it wants us to provide us with the coordinates. That's the first thing. So I look up here and I recognize that I can factor the numerator. What multiplies equal 12 and combines to give you 8, 6, and 2. The denominator factors into x plus 2 and x minus 2. Remember that a hole exists when you're able to cancel out a numerator, factor in the numerator with a factor in the denominator. So a hole exists here, but I can't just write x equals negative 2. For those that did that, if I could get half points, they'd be like, oh, you get the idea, right? But come back here, please, and I want you to underline where it says the coordinates. So how do I find the coordinates? A coordinates is an xy position. So there's the x, now we need to find the y. So here's how you find it. You take this value and you come back up to the simplified form of this. The simplified form is x plus 6 over x minus 2. And you simply take that value and you plug it in. So negative 2 plus 6, negative 2 plus 6 is 4. Negative 2 minus 2 is negative 4, and when you reduce those, you get an output of negative 1. This would be the coordinates. But then it says, write your answer also in the notation of limits. And this is definitely something that we are just starting to learn as we work through MCQ questions. So please do me a favor, and we're going to write the limit of the function g of x as x approaches that hole, negative 2. We're going to write this twice. And the limit as x approaches negative 2. Now, here's the thing. We are going to fill this box in with what it is approaching. We're going to use our calculator. What is brand new that we are just discussing the last week is I want you to make a little negative sign in the exponent position and a little plus sign. This means from the left what value is approaching. this means from the right what value is approaching. Sometimes it approaches the exact same value. Now grab your calculator, and let's do second plus 712, and go to y equals, and let's plug this in. X squared plus 8x plus 12 divided by x squared minus 4. And then we are going to graph it. Now, it doesn't look like there's a hole, but if you do second trace value at -2, you can see there's no output. So this is a nice pretty graph, and this is what I anticipate will be on your AP exam if you were asked something like this. Notice that when you come from the left and when you come from the right, do you see at -2, you see how they're both approaching the exact same value? They're both approaching, what value are they both approaching? We just did the math. They're approaching a value of -1. They're approaching a value of -1, and we just did that right here. They're approaching a value of -1. So as I come from the left, or as I approach that value from the right, it is approaching an output value of -1. In the first part of C, it wants us to use this table and then decide, is it linear, quadratic, exponential, or logarithmic? So let's go to your calculator. If you have not done so, let me move this down. Let's clear this. Second plus 712, and let's go to stat. Now I'm going to plug in exactly what I see here. So my x values are 1, 2, 4, 8, and 16. And then the corresponding y values or output values. Let's go to Windows, and right now my x's are only going down to 10. I want to show at least out to 16, so let's go out to 20. How do we show just those points? We need to turn on the scatter plot. So we're going to go the blue key and then hit scatter plot, and right now it's off. You're going to have to hit it twice generally, maybe 3 times, until on is highlighted, and then let's graph it. Does the shape of those points, if you don't recognize right now the correlation between the inputs and the outputs on the table, does the shape of those points look linear? Does it look like a directly straight line? No? Okay. Does it look like a parabola where it's a U shape up or U shape down? So let's go to our choices right now, and let's cross those out. Okay. Exponential, by the way, exponential, think of this. Think exponential rises like this. It's not like that. In fact, if you don't remember, exponential and logarithmic are going to be inverses of one another. So it is logarithmic. Now I can show you how we are able to prove this, because I believe it says to us what is it, and it says how do you know in the next part. What I want us to do is it's going to create a regression. It's going to create an equation that uses these points to model it. Do me a favor and go to stats, go to calculate, and go all the way down to number 9. Number 9 is going to be the regression model for logs. Press enter all the way through. Now how can we take this information and put it into a graph? Go up to y equals, and we can paste that in like a copy and paste from a computer by hitting the button vars, going down to statistics, then go to equation and press enter. Now when we graph it, we can see that the graph doesn't necessarily go through every single point, but it uses those points to calculate like an average to come up with this average of this graph. And so in part C, it tells us, it gives us, give us a reason why you chose log. That's what it says. Give us a reason why you chose this. Well, I have a couple different reasons that I can think of. One, I can see that the scatter plot that I created and the regression model match up. So the scatter plot matches up with the regression model that I created. Also, if this is logs, I'm just going to write logs down here. Remember, we have a base, a number behind it, and we have this value on the opposite side. These two values have to always be positive. So this is your input, okay? This is your input value. This has to always be positive. Well, look up here. My input is positive and my output is positive. These two have to always be positive. This is your input, this is your output value, okay? Got it? So that matches up right now with logarithmic as well. Also, if you notice that we can see a correlation here if we look at the inputs and the outputs. So consistently, our y values are going up by the same amount, and our x values, if we look at that, the inputs are growing, and they're growing exponentially. The inputs are growing exponentially. So there's this correlation between your inputs and your outputs. This is growing, so it's multiply by 2, multiply by 2, multiply by 2, right? If this was switched, and it was 0, 1, 2, 3, 4, and this was 1, 2, 4, 8, 16, this would be exponential. It'd be exponential, okay? And it was really easy for a lot of people. So when they chose exponential, I was like, oh, you're so close. You see the patterns, but the pattern is switched, okay? The pattern is switched. So we're looking at the output values when we look at them. The output is what's determining it, okay?